Great. Okay. Good morning, everyone. Thanks for coming and sticking around before this lunchtime. So next, I'm going to talk about Mallard, turn the web into a contextualized prototyping environment for machine learning. This is a collaboration work with my advisor Philip Guo, and I'm Xiong from University of Rochester. So machine learning is one of the most sought after skills nowadays. And if you go search for it on Google Trends, you can see there is a clearly growing interest over the past 15 years. And many people want to learn the skill, or at least they want to just play with the skill. However, machine learning is challenging to learn due to its complexities from both the theoretical part and the practical part. For machine learning algorithms, the underlying mathematics can be hard to understand, but what first challenges most people is to set up an environment where they can play with the existing code and data so that they can gain a more tangible feeling. Although there are available resources around for public access, they come in different pieces, like different operating system, programming languages, APIs, web services, source control. And all of these require end users to put the pieces together, and this creates another barrier to novice users. For example, if we are on Google image search and we want to play with the image style transferring algorithm for the images here, to prototype something like this, there are many steps to go through to set up a proper environment before we can even start to write a single line of code to touch the core part of it. So to address a similar problem in learning in the domain of learning data science, we noticed that the web can be a good substrate to lower this barrier by hosting code, data, and the environment all in the currently opened web page. So to explore this idea, we introduced DSJS on UIST 17. In this paper, we show that we can use a bookmarklet to turn the web into a data science learning environment by putting a lightweight IDE under the tabular data source on the web page. So we found that the web is a great platform for these lightweight programmers like students, learners, or hobbyists, because one, browser is really easy to get access to. Nowadays, everyone with a computer probably has it installed. And two, browsers have a pretty good cross-platform compatibility, perhaps one of the best, because they're designed to be a little bit isolated and detached from the operating system they run on. This kind of design actually help people to avoid dealing with the slightly different behaviors from system to system. And three, perhaps more importantly, the web pages that the users are currently looking at probably have something that they are interested in at the moment. So it's more motivating for them to use the data there rather than use another like standard data set, say about flower petals or human iris. So you can imagine. So all of these advantages make the web also a good substrate for doing machine learning. So you can imagine using DSJS for that, but because DSJS is bound to the tabular data sets, and we cannot guarantee that is always the case for every web page we see. We want to find a place in the browser that feels more built-in and more flexible with code and data. So by reflecting on how people turn the browser into an end-user programming tool, we realized that there is a place in the browsers with such design potentials, which is the developer console. The developer console is a perfect place to do such end-user programming because it is connected to the current open page. However, it also has its own limitations. For one, it only supports text input and output, and it and it is bound to whatever library is provided by the currently open page. Well, in machine learning, many of the interesting applications come from applying the external libraries on multimedia data like images or videos. So going back to our previous example, because of these limitations here, in the built-in console, it is not feasible to work with the images, and it is not feasible to import, say, an external JS library for machine learning. So to make the console a more capable tool for prototyping such machine learning code, we designed Mallard, which stands for Machine Learning Lightweight Breadboard. Mallard is a Chrome extension that extends the developer tools. You can find it from the developer tools panel, which is the same place where you can find the built-in one. It is designed to be visually like the built-in console, so that it has a similar basic interaction of, say, writing one or more lines of JS code, run the code, and then see the results. But we have also put some improvements to this basic interaction to make it a workflow for prototyping the machine learning code, which includes 4 steps: acquiring data, prototyping, visualizing, and augmenting the host page. So next, I want to show you what Mallard can do in the example I showed before, which is to transfer the image styles on Google image search using TensorFlow.js and ML5. Okay. The first step is to acquire the image data. We can either drag and drop from the host page to Mallard, or we can right-click on the image to import it using a shortcut menu item. Mallard supports similar interactions for images, videos, tabular datasets, and text. The acquired data is converted into corresponding JavaScript arrays that users can easily refer to in their code. And next, we want to import the ML5 library, which is built upon the TensorFlow.js, but has more friendly APIs for end users. Let me play this. So using ML5, we load a pre-trained neural net model for image style transferring, and then after the loading, we apply the transferring function to transfer the style of the image we just acquired from step 1. So please note that here the model loading and then the transferring function are all called as asynchronized functions. So we use the await expression to cache their results. And after that, we use the visualization function to show the image result, which is just like how we usually show the result in text using the console.log JavaScript API. So in this step, we showed how we can load external modules, refer to the acquired data, and visualize the outputs in Mallard. It also has other useful features that we didn't show here, like saving and restoring programming state, scaffoldings for debugging, displaying an arbitrary HTML block, or the ability to communicate between all the opened tabs so we can transfer data from one tab to another. And finally, after we prototyped with one image to test the code, you want to apply this transferring on all the images on the current screen we see here. To do that, we first acquire more images using a Mallard acquiring tool. We then write a for loop to apply the same function, and then we replace the result back to the original one using another Mallard function that keeps track of the connection of the acquired data and the and one on the host page. Okay. So in this step, we show how we can augment the host page with our prototyping results. Like how we can acquire different types of data from the first step. We also have different ways of augmenting, replacing an image, add columns to a table, or change the CSS of the attached DOM element. Great. So in the previous example, we can see how we use Mallard in this first step workflow to prototype a machine learning application. The first is to acquire different types of data from host page to Mallard and then convert them into a programmable JavaScript object. And the second is to write prototyping code with the acquired data and external libraries in a repo-style environment. And three, visualize the code outputs in images or other rich form visualizations. And four, we can push the outputs back to the host page for augmentation. So to further evaluate Mallard and this workflow, we did an informal case study where we used Mallard to prototype eight more machine learning applications. So here I want to show you three more, but please check our paper for other ones. The first one I want to show you is how we can incorporate the sentiment analysis to Amazon reviews. With the scaffoldings we have in Mallard, we can take the review text into an array of strings, and then we run the sentiment analysis using TensorFlow JS, and then after that, we color the reviews based on its sentiment score. Another one I want to show is to recognize superheroes from a movie poster using face recognition. So what's special here is we actually trained the face recognizer from the Google's image search, where we can find a bunch of photos for the actors. And this was the training was done in another tab, and after that we can import the trained model from another tab where we from another tab into this one where we actually want to do the face recognition. And later on, we can even wrap the recognition functions into a widget to make the prototyping more complete. This is by taking advantage of you can put whatever HTML you want to put in Mallard so that it's easy to prototype a button or a drop-down. And similarly, we can also prototype a search text on image feature with Mallard and an OCR library. And this is especially useful when you are looking for certain dishes on restaurants' website, but it posts its menu as an image. Okay. So to summarize, in this work, we found that web can serve as a contextualized prototyping environment for machine learning by unifying code and data within a domain-specific browser developer tool. And we validate the idea by building Mallard, a system with the scaffoldings to help users to acquire the data, work with models, and augment the host page with the model's outputs. Okay, so before I end my talk, as a final note, I'm currently looking for full-time jobs, and if you have openings and are interested in my work, we should talk. And thank you for your attention.
Which is, I love the example of the image transformation. Mm-hmm. In some ways, that made me think of Mallard as much as a glue programming system that took a pre-existing machine learning action and you glued the image results to that transformation. And so I'm curious, do you think of Mallard more as a glue system that happens to be particularly valuable in the machine learning area, or do you think of it actually more intrinsically as a machine learning system?
I think it definitely can work as a glue system, but I guess it's what really is trying to copy how you feel when you you are on your browser and they see you can see people are already doing that. Say you are on your Reddit homepage and you can grab all the titles of the articles and you can just pop out your browser console and write, say, 2 lines of your jQuery code, and then you're all set. So this is basically to take this experience from the text into the world of images and videos and all more multimedia stuff, which are one of the main fields of doing machine learning applications. So it's imagine one day you are browsing, you see this cool picture or video here, and you happen to know there is a interesting library you can apply on, so you can just pop it out just like how you do the text thing in the console.
Great, thanks. And I think I hear the gumbo calling, and let's thank our speakers one last time and enjoy lunch.